Thank you. A few months ago, Curtis Helm, a lot of you know him, approached me and said, Dr. Bob, you ever given that talk you give to all your classes about the history of the oil and gas in the Permian Basin? Have you ever given it anywhere else but in class? And I said, no. He said, well, would you like to give it at the WTGS symposium? I said, well, Curtis, I can't do that in 25 minutes. There's a long history. So he graciously agreed, along with the board, to give me a little more time, and there will be a test at the end. Okay, so this is going to be basically the history of Gulf oil, but a lot of other stuff thrown in. Every company, every major oil company, be it Humble or any of the other ones, Pan Am, some of you may remember these names, they all have a history in the basin. And they're all very similar to what we've got for the Gulf history. But having worked for Gulf and having had access to some in-company information, it was easy for me to put together a talk on the history of the Permian Basin as seen through the lens of the orange disc. Okay. Which way's forward? All right, okay. Special thanks to a couple of people. F.O. Mortlock, I never met the man, but I have some publications, in-house publications that he put together that helped me put this presentation together. A lot of the graphics were done by him in 1958 for an in-house thing. And 58 is an interesting time frame. We'd been producing in the basin for a little over 30 years, and we were transitioning from the primary history of the basin into the waterflood history of the basin. So some of the graphs I have kind of talk about the primary history of the basin, which is pretty important to understand. And then Bob Ward, who was my boss for a number of years and a good friend of mine, and he and Bob Lindsay and I and a couple other people would go to lunch, and he would tell us all these stories, and embedded in them was a lot of good history. So I'd like to thank him. And then, of course, everybody who's gone before us has provided something for us. We are not the giants. We are standing on the shoulders of giants. So we all know where the Permian Basin is. I can kind of go through a couple of slides. You may not know that the Permian Basin gets its name from the Perm in Russia, which was designated as Permian back 180 years ago. So we are the Permian Basin. And it was designated such because the people working in the surface 100+ years ago were finding Permian age rocks all around the basin, the Guadalupes, the Apaches, the Sierra Diablos, East Central Texas, the Marathon area. So the assumption was at that time that since we're seeing these outcrops dipping into the basin from all directions, there must be this huge basin out there, and it appears to be Permian age. And that's really how we got our name, the Permian Basin. It's actually built on once we drilled into it, we found things like the Central Basin Platform, which we didn't know about, and also that there was a precursor to the Permian Basin called the Toboso Basin, which was Lower Paleozoic. Everybody know where we are? Okay, we'll go on. As I said, this is going to be based on Gulf's history, but it could be anybody's. Gulf didn't start in the Permian Basin in Midland. It started in Fort Worth. A lot of companies had offices, Fort Worth, Dallas, Houston areas. Very few companies started with major offices in the Permian Basin itself. And one of the reasons for that was that the first production they were trying to exploit wasn't in the Permian Basin. It was in north central Texas. Whoops, now I've done it. What did I do? Okay. There were fields in Ranger and Burke Burnett up to the north and Electra, and there was production starting to develop in the Amarillo Uplift, so they had their offices here. And one of the reasons was communication lines. Highway 80 was a dirt road, basically. There was a rail line. Certainly we had no internet and no superhighways, so you kind of moved where you were near the production. So anyway, a lot of offices started in Fort Worth, but moved on. When I worked at Gulf in the early 80s, we still had linen land maps that had been drawn by the drafting team in Fort Worth back in the second decade of the 20th century because there were no commercially available land maps. And so all the companies had their own land maps. And they were very, very accurate, very, very good. Now we have Midland maps, which are excellent, but back then everybody had their own. But with the advent of some interesting events in the Permian Basin, Gulf decided that to get closer to the production, because of those long lines of communication, we needed to move closer to the basin, so they moved their office to Sweetwater, in part because they were near the Westbrook field. That was in 1922. Some of the early wells in the area, in the basin. There was a well just south of Midland. It was the number 1 Bryant. It was spud in July of 1919, and it TD'd at 4,478 feet 19 months later. Okay? We can do that now in 3 days, 4 days. Okay? It took a while. Part of it was that all the parts, if anything broke, they had to go back to Fort Worth and get them shipped out on the rail line. So, I mean, or they had to make them themselves. So it took a lot of time to do things back then. But this is key well because it's one of the first wells that actually penetrated beneath the red beds. We had some wells out in Loving County that actually made production in 1920 prior to some of the major discoveries. And in fact, the Toya Bell number 1 Russell and the Pecos Valley number 1 Wheat, as in the wheat field, produced significant amounts of oil from the Delaware Mountain Group. However, they were so far away from any means of getting the oil to market that it was kind of like, well, if it's not going to flow thousands of barrels, we're not going to complete it. And one thing I tell my students is look at some of those really old early wells that show up on a map as a dry hole, because they may have been a dry hole because they just couldn't have a market. So they could have been a producing well. The Westbrook field was discovered in 21. That's why Gulf moved their office to Sweetwater in 22. And it was one of the first more or less significant fields in West Texas, and it had the nice happenstance of being relatively close to the railroad. Gulf's first test was up there, the Westbrook field. The number 1 Crawford, drilled in 23. It made some oil. It TD'd in the San Andreas, but it was not commercial. Today, that would certainly be a commercial well. Commercial well back then was, if it didn't flow to surface, if you couldn't nitro it and make it do something, it was a dry hole. So anyway, their first effort was a dry hole. Now, a lot of the older hands, and me included, have experiences where if management let you drill a well and it was a dry hole, that was the last thing you got to drill for a while. But they continued to pursue these things through the early 1920s. The Texan number 1 University, which is the Santa Rita number 1, the well that everybody's familiar with, located in southwestern Reagan County. The story goes that the rig broke down there, and that's where they decided to drill. It was not really on the highest part of the structure. It was off structure, but it was good enough that it set off the development of the Big Lake field. One of the things that initiated interest in the Permian Basin was a publication actually by the Bureau of Economic Geology and Technology, the precursor to the BEG, back in 1916. This is the 3rd edition, 1919. And it was a discussion of the potential for oil and gas, in the Permian Basin. And one of the places they talked about was Reagan County, and that was one of the things that interested the people who were first into Reagan County looking to drill a well. So we go back to the publications. Whether you know it or not, one of the early publications of the BEG actually led to one of the early discoveries. There's the Santa Rita number 1. Came in as a gusher. It produced for 67 years. It was finally plugged in 1990. The well must have been at least 20,000 feet deep. Based on all the little pieces of ring of casing from the Santa Rita number 1 I've seen in different offices in different places. Yeah, people are laughing know exactly what I'm talking about. So Reagan County, one of the highlights early on, but before that, there was other activity in the basin, and just kind of go through some of the stuff that was going on in Pecos County. There was actually the Turney oil seep down there. Whether you know it or not, we actually had oil seeps in the Permian Basin. A lot of people don't even know that. It was drilled, and there were several shows of oil between 630 and 1,300 feet. They encountered sulfur, and later on they went back and looked for sulfur in the area, and there are actually a number of sulfur prospects along trend very close to this that actually define the kind of the southwestern edge of the Central Basin Platform now as we know it. In 1916, the Southwestern Company drilled another well in the area, the Turney, again drilling to very shallow depths and another dry hole, but they were still after it. They figured if there's oil at the surface, there's got to be oil at some depth. That's what Colonel Drake said back in 1859. So there were a couple other wells drilled, the Wonder and the Miracle wells. That's the actual names given to the wells. And they struck oil very, very shallow, very close to the oil seep. The Miracle well made 5,000 barrels of oil on the first day and never made another drop of oil. Okay? I wonder if all that came from the reservoir or some of it came from a tank truck. So they eventually drilled some more wells around the area. There was minor success, but they all watered out pretty quickly, and everybody agreed that they were probably looking at some shallow accumulation that had migrated up from a deeper horizon, and they weren't quite sure where the deeper horizon was. The Graham Troy #1 Johnson was one of the wells that drilled a little deeper, and it was located a mile east of the oil seeps, and it had a number of good shows in the Permian, and but not productive. But the investors got to infighting, and somebody may have actually salted the well. In other words, poured well down the well bore, and then said, "Oh, look, we got oil in there." But it was eventually abandoned. Another well, the Pintle Dome Devlin, drilled to the southwest of the oil seep and the Graham well. Word got to the newspaper. Sorry, Mela, if she's still here. That the Pintle Dome well making oil practically proves the field. And very quietly later on they said, actually it was a dry hole, never mind. So there's the Troy well here in Pecos County, northern Pecos County. It's on the Central Basin Platform, which is we know it today. And there's the Pintle Dome well. Powell Field was after Westbrook Field and after Big Lake Field. Powell Field was one of those wells that, one of those fields that was developed. And Powell Field is also known as the World Field or the Powell World or the World Powell, depending on where you are. By the end of the 1926, it had produced 300,000 barrels of oil, which was a considerable amount of oil back then. And Gulf, it had leases in there, so we actually had production in the Permian Basin. So the relationship of the Troy well and the Pintle Dome are kind of interesting. They didn't know back then about the Central Basin Platform. Remember, they thought there was this Permian Basin, a kind of bowl-shaped thing. The deeper part of the basin may actually have been where they were drilling. But as I said, they found a trend of sulfur deposits that extended up in this direction. We know now that that's probably related to oil migration as part of the residual oil zone development. And so those are kind of key wells. Here's the sample logs from those two wells, and this is the Devlin well. You can see a real thick section of the red beds before you get down to the evaporites and eventually down into the Guadalupean carbonates. And here's the Troy Graham well, very thin section of red beds, a somewhat thinner section of evaporites, and then very much shallower you get into the top of the Guadalupean carbonates. And that's the relationship of those two wells today on the producing zone map. This is Gomez Field down in here. That's the western edge of the platform. So you can see that the early geologists had an idea that there was something going on. It wasn't just simply this bowl. There had to be something sitting right in the middle of the Permian Basin based on information like these red bed thicknesses and evaporite thicknesses. We know today, this is an old 2D line that's been annotated. We know today that the Pinel Dome well is located in the basin, and the Troy is just on the edge of the platform over in here. Of course, they didn't have access to this back in the early 1920s. In fact, they didn't even have 1D seismic yet. So that kind of information, and tied in with other surface information, shallow subsurface information gained from the wells, and a lot of looking at water well information, and surface structures. For instance, the west-facing escarpment, I'm going to push the wrong button again. The west-facing escarpment on the Llano Estacado in here, they thought back in the 20s that, well, maybe this is kind of indicating that there's a crest of a structure in here, and what we're seeing is dip on the surface beds back to the east. So using wells like these down here, the deep wells over here with a thick red bed section, they started to develop a theory, a lot of companies did, that there was something going on in the center portion of the basin that they weren't really very familiar with. Something at depth they couldn't tell. But you know, they all had surface mapping crews out here mapping the surface structures. The theory being that if you had a surface closure, it probably translated in depth to a closure, and therefore you'd look for something. Kind of like what we do with air photos now, but back then they didn't have them. They actually went out with riding horseback with mule trains. And the last time they did that I have evidence of was in the late 1940s. Gulf had a party that went out to the Sierra Vieja north of Presidio. Geologists on horseback with pack mules and doing plane table and alidade and sample collection and stuff. So this was a primary methodology of determining what was going on by looking at the surface and projecting into the subsurface. This is the map that Kip Harper, the geologist, and others at Gulf drew based on this information about surface structures and thickness changes in the red beds. Remember the Bryant well in Midland County had a thick section of red beds. You had thick sections of red beds here and down there, and they were starting to develop a concept that there might be some sort of major structure in the subsurface here in the middle of the Permian Basin. Well, the geologists got really excited about this, and remember, they're now in, I think at this time they were in San Angelo. They went to Fort Worth to the office, to the headquarters, the division headquarters, and said, we think we really have something here, and we really want to buy a lot of acreage out here. And the management at the time said, that's nice, as management is wont to do, and as management is wont to do, it's something new and different. They stuck it in a drawer and went on. It wasn't until a couple of years later, a year and a half to 2 years later, that new management came in, a guy named Ben Belt, who trained Bob Ward, or Bob Ward knew him anyway. He came in, he got that map out, and he said, I think there's something here. He got back with the geologists. They decided to take it to Pittsburgh headquarters because Gulf was supported by the Mellon Bank in Pittsburgh. And in fact, when I worked for Gulf, my checks were drawn on the Mellon Bank in Pittsburgh. But they went to Pittsburgh, made a presentation. Management there said, that's nice, but we're not going to give you all that money that you're asking for. We'll give you about a third of that. So they took it and they bought a lot of land. Talk about that. Oh, by the way, this map was hanging in the Petroleum Museum for decades. And when they put in the minerals exhibit and the cars, it got put into storage. And earlier this year, Paula forwarded me an email from Kathy Shannon at the museum saying, do you have a copy of that map? I understand you do. We can't find it. We don't know what we're looking for. So I took her my copy of the map, and eventually they did find it, and it's going to be rehung in the Petroleum Museum when they finish their work. So anyway, the geologist had this map and got the management to agree. It's either slow or I'm not doing something. No, go forward. Okay. They agreed that because of this understanding of the shallow beds in the basin, that they were going to purchase as much acreage as they could along that, what they believed to be an anticline, extending on up through this area right in here, which we now know is the Central Basin Platform, which they thought was an anticline. Okay, before they purchased all that acreage, this was their acreage position, Gulf's acreage position in the Permian Basin. Like any good management team, they had scattered acreage everywhere, hoping to be lucky a little bit. I don't know quite why they bought that big block acreage down there, but they did. But anyway, this was their position before they were given the permission to buy all the acreage in the Permian Basin. These are some of the leases they purchased, the size of the leases, and how much they paid per acre. There's no way you're going to get a lease for 13 cents an acre anymore. Probably not even $1,300 an acre. But you all recognize many of these names. These are some of the larger ranches that they purchased and the purchase price. Estes, Waddell, Henderson, McKnight. Fields are based on some of these. They got lucky. I understand they got lucky in purchasing some of the acreage where they did, but boy, they did a good job of purchasing nice blocks of acreage in really nice oily places. And this is what the map looked like after they purchased a lot of those large blocks of acreage. So you can see how they've got a lot of acreage along what they call the anticlinal trend, which now we know is the Central Basin Platform. So they had 200,000 of these acres were acquired with just 9 leases, and my understanding was it was about a dozen sheets of paper. Leases back then were real simple. Okay, now it's a book, but back then it wasn't. The problem was in some cases that they took term leases because the lawyers, God bless them, the lawyers thought that you couldn't potentially hold a lease in perpetuity even though you were producing oil. They thought that eventually the courts would overturn leases that didn't have an expiration just based on how long you produced oil. So they convinced management that some of these anyway should be term leases. Term leases being leases that were only taken for a certain period of time. Well, they took them in 1925. They took some 50-year term leases, and they took some 75-year term leases. The 50-year term leases were on the Waddell properties. So they were expiring in 75. Well, in the mid-60s, the engineers, bless them, decided that they could get all the oil out that it was worthwhile from the Waddell properties by 1975. So we shouldn't really try very hard to negotiate an extension to the lease. By the early 1970s, they went, oh, well, maybe we're not going to be that successful. And they decided we've got to do something, so they tried to work out a deal. Unfortunately, it was too late. Southern Royalties, Burlington, whatever you want to call it at the time, I think it was Southwest Royalties, top leased them. So in 75, they came in and said, Gulf, move. These are our properties now. And Gulf said, okay, well, we're going to take all of our iron with us. We're going to take all the pump jacks, all of the pumps, all of the tubing, everything else, the surface facilities. We're going to take it and go away because you've top leased the lease. You haven't gotten our equipment. And so Southwest said, whoa, wait a minute. Maybe we can work out a deal. So for a number of years after that, Gulf operated the property for, I think, 3% of the total oil production. And when I started working for Gulf in production in 1981, excuse me, I was working Sandhills Field, and my boss was a guy named Benny Benson in the Odessa office in Gulf, but we actually worked for Southwest Royalties. And I'd go out to log a well, and I would go out and I'd have gotten my samples and I'd have run my strip log and I knew where the shows were, and I'd be out there. I'd call up the engineer at Southwest Royalties and say, we're going to be logging a well today, and he'd come out and he'd meet me, and they'd run the repeat section. We both take our repeat sections, go to the hoods of our cars, and make our own estimation of the purse. And my boss had told me, always add 2 or 3 extra sets of perfs. I go, why? He said, you'll see. So we get out there, and we had to horse trade on where we'd perf the wells. So I'd always have 2 or 3 that I could say, well, I really don't, these are okay. Why don't we just throw those out, and you throw those out, and then we'll all agree on the rest of them. And that's how it worked. A very, very efficient way to run a field. So anyway, so that was the Waddell leases. In the HSA, Hutchison Stock Association leases, that was a 75-year term lease. That's Northward Estes, up by Monaghan's. And same thing occurred. It was top leased by a company. And the same kind of agreement was made. Chevron went on. At that point, it was Chevron. Chevron went on. But again, it was one of those things in the late 1980s, early 1990s, knowing that the leases are going to expire in 2000, they said, we need to evaluate all the reservoir within the HSA leases. Let's look at all the interval between the Pennsylvania, the wagon wheel pen that produces, and the Yates and Queen. That's 5,000 feet of non-producing interval. They said, Bob, do you want to do that? Okay, yeah, well, all right, well, where are my digital logs? Well, can you use paper? I'd prefer digital. They'd finally give me a computer, by the way. I said, well, where are the digital logs? Well, we saved a little money. We digitized across the Pennsylvanian, and we digitized across the Yates and Queen, but we didn't digitize that 5,000 feet in between that doesn't produce. So I had to do it all with paper. And I did actually make a new pool discovery there. But it didn't do anything. They still let the field be top leased. Anyway, term leases. You may actually run into them at some point. So a little bit of digression here about land. I've actually interspersed stuff about land, but I wanted to put this information in. Vacancy strips. There are some famous vacancy strips in the Permian Basin. Like I tell my students, the pioneering surveyors out here had to deal with Indians and buffalo and rattlesnakes and not much else. And so, you know, all these surveys were done either for the railroad or by individuals or by companies. And they were all basically trying to survey areas, because once you surveyed an area, you could patent it. You could go to the county courthouse and say, this is mine, here's how it is, and then sell portions of it. You know, for instance, if you ever work along Pecos and Crane county line there along the river, you'll see all these really long strips that enter towards the river. And that's because they wanted to survey it so that everybody who purchased land had access to the water. Okay, well, it makes sense. But Texas has got these real screwy land systems as a result of that. And one of the problems is that different companies, different groups, different people were out there surveying. And sometimes surveys overlapped. Sometimes you got things called vacancy strips. And the most famous one is the one that runs right through the middle of Yatesfield. And Fred Turner was in the office working on putting together the land maps from the surveyor's notes, and he went to his boss and said, there's a problem here, and I can't quite figure it out, but his boss said, don't worry about it. So Fred quit, went to the courthouse and patented the land and became rich as a result. Let me show you how that worked. Okay, so this is a land map as it was assumed to exist through the middle of the Yatesfield. This is the land map as it really existed through the center of the Yatesfield. And I know just looking at that you can't really see very much. Well, forward one. Okay. The assumption was that that was the border between those surveys. The reality is that there was a vacancy strip. It was the first evidence of continental drift. Okay. The surveys didn't match perfectly. There was a gap in between them. So what Fred Turner did is he went and he patented all this land, which sums up to 300 some acres, but it's in the heart of the Yatesfield. So after many years of litigation, and he obviously it was his land, but you know everybody else is going to go, but wait, I've been drilling that for years. No, you haven't. It's mine. Give it to me. And the Turner Mansion, Museum of the Southwest. Museum of the Southwest used to be known as the Turner Mansion. That's where Fred Turner and his wife and their daughter moved to after he wound up patenting his acreage. And there's other ones around the basin. Next slide. Here's one right in the middle of McElroy Field. It's between the university block to the north and the railroad block to the south. That's CCS&D Railroad. And this is University Block 30 to the north. Literally, there's this vacancy strip that runs right through the middle of it. It's just one well wide. And it was, Mr. Landreth said, hey, I found this vacancy strip. And after litigation, he was allowed to drill. So, whoops, go back. So he started to drill his wells through here, and Gulf started to drill a double set of wells on either side of his lease, trying to, as fast as he was drilling wells, they were drilling wells, each one trying to drain the other one. Okay, so these vacancy strips do exist. So if you wonder why you wind up with little weird things like this in the middle of your field, this goes back to the surveying in Texas. Bless those surveyors. Okay. So you might think this is over and done with, right? There's no more vacancy strips. Well, in 1987, when we were doing some work up in Motley County, our land department actually found a 40-acre vacancy strip, and or square in this case. And they went to the county and basically deeded the land over to the county. Chevron didn't want to own it. Excuse me. But this particular 40 acres never produced, but in the section immediately to the west of it, there's a series of wells on 80 acres that have produced over 1 million barrels of oil total. So it could have been productive. In this case, it wasn't. Lease line protection wells, I kind of talked about these. Gulf did. They built the double stack of wells on either side of the Landreth lease. Next slide. Now let's look. Now looking down at McCamey Field, let's look at this quarter section lease of Gulf's. There's the first 10 wells that they drilled in their quarter section. Okay, they're all lease line protection wells, but everybody else is doing that too. So it's not like it's unique to Gulf. Everybody was doing it. Okay, but for 20 years, those were the producing wells in that quarter section. Now, of course, it's all been filled in now on 10-acre spacing, but just imagine what this might do to the history match. Just imagine, put your sequence stratigraphic hat on and think about how are you draining this quarter section? Well, you're not really doing a very efficient job of it, but as long as you can make proration units, it doesn't really matter where you drill. But for 20 years, this is a map from the mid-1940s, 20 years or longer, these were the producing wells. So sometime, if you want to amaze your engineer, you can ask him about where the original wells were, because now these wells, these wells are all just part of a unit, so they have unit numbers. You can't tell what the original wells were and where they were drilled and how long they produced this really funky kind of pattern of wells. So keep this in mind when you're looking at a field, that just because there's a nice uniform pattern distribution of your producing injection wells now, it doesn't mean it was that way forever. It didn't start out that way in a lot of fields. Okay, so that was the digression on the land. I think that's kind of information. I know there's a lot of old gray heads in here nodding in agreement, or either that or they're falling asleep. But for the younger people, I think this is probably stuff that you've never seen before, so it's of interest. So some of the early fields in the Permian Basin, there's Yates, Big Lake, World, McCamey, McElroy, Waddell, Goldsmith, Hendricks, Northward Estes. Does this sound like a litany of the Gulf leases that they took? They took a lot of leases in some really good spots. And I said part of it had to have been serendipity. But they took these leases in 1925. Keep that number in mind. Remember, I already mentioned it. 50-year term leases expired in 75. 75-year term leases expired in 2000. So those were leases taken in 1925 as a result of that land rush early on. The McCamey Field, came in at 70 barrels a day. Less than a month after the 300,000 acres had been acquired. So if they hadn't gotten the land when they got it, if that had sat in the manager's drawer for another 6 months, Gulf wouldn't have been a big name out here. The McElroy Ranch lease taken in March of 26, only a month before the Church and Fields University lease well completed for 190 barrels a day. So it's another one that wouldn't have gotten picked up by Gulf. And in 1926, Gulf's first well, the J.T. McElroy, was successful as a wildcat in West Texas. Yates Field was also discovered in this time frame. Originally, the Marathon, well, it was Mid-Kansas Oil and Gas back then, and later Ohio, then Marathon. That was completed for 135 barrels of oil a day at 997 feet. We're not even getting started at 997 feet today. It was again deep into 1150 and produced 70,800 barrels of oil a day. We think a good well is one that produces in its entire lifetime 70,000. It produced it in one day. One of the bigger wells produced 204,000 barrels of oil per day. Gulf's best well was the number 13 Yates, which completed for 125,000 barrels of oil a day. And after 30 years, it was still flowing oil at 1,545 barrels of oil a day and had a cumulative production from the one well of 14 million barrels of oil. Okay? We would bless ourselves if we ever got a well that did that well. Some of the other major lease acquisitions, the G.W. O'Brien, which is north of the HSA, both in the North Ward Estes field. The Waddells over in here, Dune and Sandhills field. Gulf's number one McKnight, one of the wells. The Keystone leases in the Keystone field up here. These secured Gulf's position early on as a major producer, but all the other major companies were doing this kind of successful development of the Permian Basin at the same time. I'm just showing you what one company was doing at the time. Just a little verbiage. I got a whole thing on the Yates for my students. The interesting thing is that this came in on October 28th of 1926. It was the 70th birthday of Mr. Yates. He got a nice birthday present when the first well came in. And, oh yeah, then that's the, let me go back one. There's the Yates family house. I doubt seriously they lived in there very much longer after the discovery. Okay, although probably somebody did. The discovery of the Yates field was called the Queen of the Pecos. I mentioned the well that produced 8,528 barrels of oil per hour, or 204,000 barrels of oil per day. And the Yates field was capable of producing 5 million barrels of oil a day. This is 1929 now, which was almost double the entire oil production in the United States. But of course, those of you that are familiar with the history of Texas oil and gas know that soon after that, the East Texas field came in huge, as Donald Trump would say, huge. And so that put a dent in West Texas production. In fact, between the stock market crash in 1929 and the East Texas field of discovery, closer to markets, closer to refineries, et cetera, a lot of the activity in the Permian Basin didn't cease, but it certainly was greatly diminished as a result of these extraneous factors, if you will. Now, people kept drilling wells, but nowhere near at the pace that they had in the late 1920s. Some of the other notable things, the Waddell leases are proven by the number 2 Waddell. So the number 1 wasn't a really good well. Number 1 may not have been a producer. That's interesting. So again, suppose management had walked away after one well. In 1929, the number 4 G.W. O'Brien became the first producer in the G.W. O'Brien leases at Northward Estes. I always wondered what happened to the 1, 2, and 3. Okay? And so you've got a lot of these cases where even though they had these big leases, they weren't necessarily immediately successful. In this case, it took 2 or 3 or 4 wells sometime to establish production on the big leases, because even though they had these nice blocks, not everything was productive. We know that. So Gulf produced over 16 million barrels of oil in West Texas in 1929, but like I said, and in the early 1930s, there was not a lot of development going on. Some of the other things, by 1935 now, all those leases that were taken in 1925 and 26 as a result of that 300,000 acre buy, some of those leases, many of those leases that hadn't had production established on them, were coming up against the end of their primary 10-year term. So this started another flurry of activity in the mid-1930s for both Gulf and other companies. So a second surge, if you will, occurs at this point with the development of more production, more field discoveries, more leases being HBP. You can see that in 1935, nothing like waiting till the last minute. Okay, I had 3 students yesterday at 2:30 in my office wanting to print posters off for the core workshop Friday morning, and I told them in advance I'm leaving at 3:30. Okay, nothing like waiting till the last minute. So, Keystone Well was completed 17 days before the end of the lease. The Goldsmith discovery was January 31st, completed in June. The lease is set to expire in August. The McKnight discovery for Sandhills was spud in April of 35, just months prior to the lease expiring in July. So, you know, like I say, nothing like waiting till the last minute. But at that point, there was not a lot of incentive to wait to do anything earlier than this. At this point, sometimes a student goes, well, what about New Mexico? You know, well, New Mexico, there was a lot going on. In fact, New Mexico was more active earlier than the Permian Basin, well, the Texas portion of the Permian Basin. But since we're in Texas, we'll just call that the Permian Basin. I don't know, many of you probably worked in companies where you had state line faults on your maps. The guys working in New Mexico would have the trend going this way, and the guys in Texas would have one going this way. Okay? But Mexico is very active. Just interesting that the companies that were active in New Mexico weren't necessarily the ones active in Texas, and vice versa. So this is just a kind of a summary of some of the early production successes in the New Mexico portion of the Permian Basin. In fact, you can go back all the way back to 1909 and find oil production in New Mexico long before there was a lot of established production in the Texas portion of the basin. But like I said, there's this kind of mental disconnect between Texas and New Mexico. And if Ron Broadhead's in the audience, sorry, Ron. More activity prior to some of those major discoveries in the Texas portion of the basin. This is interesting. The Hobbs field was discovered as a result of a magnetic survey identifying a structure and confirmed by gravity in 1926. So these are some of the subsurface methodologies they did have access to in addition to surface geology, shallow beds. They did have gravity and magnetics. Of course, those of you that are familiar with Hobbs, Hobbs sits right on top of one of the big, deep, lower Paleozoic and Precambrian cored structures in the basin on the Central Basin platform. So what they were actually seeing was probably the Precambrian, but it was the core for a shallow producing interval. So Gulf eventually moved their offices to Midland. They were on the second floor of the First National Bank building. And the reason they moved to Midland, they'd been in Fort Worth, they'd moved to Sweetwater, they'd moved down to San Angelo, and, you know, kind of trying to keep getting closer and closer to where the production is. They finally established their office in Midland because there was railroad, there was telephone lines, there was a hotel, the Scarborough Hotel, and there was a telephone rail, road, Highway 80, office space. There was office space here. So that was where the Gulf's office was. All right, so this is a production by year for Gulf only from the beginning, 1925. And you see the rapid rise in production to 1930, and then it drop off to 1935. That's when East Texas and the stock market crash had influenced production in the Permian Basin. And then there was the, oh shoot, our leases are expiring on primary terms, let's get back to drilling. So there's 1935 when they get back to drilling, and there's the increase. And you would have expected a larger increase during the Second World War, but they needed the steel for tanks and planes and guns and stuff. So laying pipelines from an interior to the U.S. Oil fields to a refinery on the coast wasn't a high priority. So they did produce a lot of oil, and proration, well, didn't have proration, but some of those wells, Bob Ward said that some of the wells in McElroy Field were just turned on and made 1 million barrels a year through the war years as part of the war effort. And then you can see after the end of the Second World War, it ramps up again, pretty much flattens out, and then that's probably the first major year, about 1958, when we start to see the impact of major water floods being put in the Permian Basin. So this is a chart basically of what the primary production looked like and the influence of man-made variables, if you will, on the production in the Permian Basin up to the end of the age of primary production in about 1958. Gulf had produced 500 million barrels of oil from the Permian Basin by then. And there you can see some of the distribution of the production in the fields. So they had been pretty successful in developing a lot of production. They got some goat pasture, but everybody does. But they've been fairly successful. Excuse me. Considering that they only had cable tools, and by the 30s they did have some rotary, considering that a lot of the cable tools were the method of choice for drilling wells, we were kind of lucky in the fact that most of our major reservoirs are shallower than 5,000 feet, which are easy depths reached by cable tools. Just imagine if most of our production were down at 10,000 feet, it probably wouldn't have been established until a decade or two later than the 1920s and 1930s. So our history goes back, thanks to our shallow reservoirs, into the 1920s. And then by 1958, which is when I'm talking things through here, you started to see the development or the drilling of some of these deep gas giants in the Delaware Basin. Obviously, they wouldn't have been thought of to be there early on. But this is the estimation of the oily reservoirs in the Permian Basin and how many millions of barrels of oil that they estimated to have. Of course, these estimates are short of where they are today, but that's where they thought they were, at least in the 1950s. So what were the tools? I've kind of gone through them. They used surface structures. They used water wells to map shallow horizons. They did with the belief that a shallow closure represented a deeper closure. I mentioned magnetics and gravity. They had single-fold data starting in the 30s. We all know, you could probably wake us all up at night and say, when were the first electric logs run in the Permian Basin? Mid-1930s. Okay? So from about 1925 to about 1935, they didn't have a lot of really definitive tools to work with, but they did have some tools. This is a chart that shows the percent of fields, major fields, expressed by the different exploration methods. So only 14% of the major fields are expressed by surface features. About a quarter by magnetics, about a little less than half by gravity. Shallow beds, a little bit more than half. 1D seismic actually was pretty good at the time, and obviously drilling is 100%. But you can see that there's a variable ability of these tools that they had available to them to express the fields that they were looking for. Of course, we know today one of the major components of our catalog of reservoirs in the Permian Basin are stratigraphic traps. And none of these necessarily would have been expressed, none of these would necessarily have expressed stratigraphic traps. So we're talking mostly about the structural traps in the basin. I'm not quite sure about this chart, but it was given to me, and I'll say, okay. The number of expressions that you might expect of the fields expressed by, and really looking at any one, you might expect anywhere from 15 to 25%. If you start adding them together, it doesn't necessarily increase your success rate, which I thought was kind of interesting. And in fact, if you hope to have all five, surface, magnetic, gravity, shallow horizon, and seismic, if you expected to have that, only 4% of all the fields showed up on all of those. Okay? So these guys had a lot of smarts to find the fields that they did. And this is something else that I think is really interesting. Again, this is 1958 data, so we're looking at primary production primarily. And there were, at that time, this is again 1958, over 500 fields that had produced less than 1 million barrels of oil. And only 3 fields that were in the billion barrel oil category, or more than 500 billion. Now, of course, we know we'd shift that a little bit further than today because we've produced more, but this is just from primary in the first 50 years. So that's an interesting curve. Drops off pretty quick and flattens out down here. If you look at the production, obviously what you want to do is you want to find some of these guys out here because that's where all your major production is coming from, and it curves down to next to nothing for the fields that have produced less than 1 million barrels of oil. But I always said that this, finding some of these was like you're on the African plain and you're finding camp meat for the guy. You're out shooting gazelles while these other guys are out looking to shoot elephants. Okay, if you can shoot a gazelle, you can shoot an elephant. And so the gazelles are down here. These are the elephants. So a lot of times you get your practice on looking and finding 1 million barrel oil fields. I have a new pool and new field discovery in the 1 to 2 million barrel range. So I'm relatively successful, but I've also got 2 down in the less than 1 million barrel range. Okay, so, and unfortunately I don't have any at the other end, but very few of us do. But one of the things I think is interesting, I'm going to go back one slide. I think that this is very often the signature of any relatively unexplored basin relative to size. Now the numbers may change, not a problem, but you have the potential for a whole lot more small fields to be discovered. Many of them are going to be stratigraphic traps, smaller ones, with a small number of fields in the giant range, the elephant range down the other end. And I think this may be a distribution for a lot of fields. So I take some issue with the USGS estimations of the reserves when they looked at some of these basins and they say there's billions and billions of barrels of oil, but they've already drilled a few discoveries and they're down at the small end. Well, you're assuming that there's going to be a huge number of fields at the big end. There may not be. Because if most basins have this distribution, you're only going to find a couple of big ones. You may have the potential for a lot of small ones. Okay. Yeah? Okay, sorry. This is field size. Okay. A couple of years ago, I ran across this presentation by the BEG, by Kim et al. And this was for Yates gas alone. This is just Yates gas. This isn't Yates oil or anything else. This is just gas from the Yates interval. And you can see that back in the 30s and 20s, they really weren't interested in gas. Even into the 50s, it wasn't until the 60s and 70s that those became major targets. And that's to be expected. Gas versus oil. Next. But this is the one that caught my attention. This is the the distribution of field size for gas reservoirs in the Yates. This is a subset of that chart I showed you before for the oil reservoirs. It has the exact same distribution. Okay, and I think that's a significant thing when you think about frontier basins, that you might see this type of distribution from one basin to the next. Well, we know our reservoirs in the Permian Basin. Most of our oil comes from the Permian. Second is the Pennsylvanian, and then the Ellenberger. This is at the these are the numbers, the original primary reserves assumed to be present in 1958, and if you add these up, they come nowhere near 100 billion barrels of oil. Okay, so we keep adding to that number. We're up to 100 billion barrels of oil now. Well, how much oil has the unconventional resource plays add to our reserve estimates? It may have doubled that to 200 million. And we also believe that the residual oil zones have the potential for maybe adding another tens of millions of barrels of oil to that number. So our reserve estimates keep changing through time as we know more and more, and we find out more and more. Well, today there's over 133,000 old wells in the Permian Basin. That's producing wells, injection wells, et cetera, et cetera, et cetera. There's been well over 200,000 wells drilled in the basin total. In 2003, we produced almost 3/4 of all the oil in Texas. In 2013, that's the last year I had figures for, we were down to producing 57% because of all the other unconventional resource plays that had entered the pipeline by that time. In 2003, all top 10 oil-producing counties in Texas were in the Permian Basin. In 2014, only 4. Upton, Andrews, Midland, and Martin are in the top 10, and they're 6, 7, 8, and 10, I think. The first top 5 producing counties are now in the shale play. But we still have a lot of oil here. We still have a lot of potential. I think it's important to understand our history so that we know exactly where we are relative to where we've come from. Because I know there's a large number of people in the audience who may have only been here 5 or 10 years, and you just need to know history started a long time ago, not when you started here. Okay, thank you.